In this demo, I will show you how stateful sets work. For this, I will use Cassandra. I am here in my Git repository. There's a directory StatefulSets, and I have a cluster running using kops with 4 nodes, 3 nodes where I can schedule something on. I'm going to deploy Cassandra, and Cassandra is a database. You don't need to know much about it to be able to deploy it. It's a database that needs static host names, so they need to find each other, those nodes, otherwise it cannot work. And to be able to find each other, you need those static host names. So let me show you what is in the YAML file. We have kind stateful set. We give it the name Cassandra. We want 3 nodes. Every node in Cassandra is the same, so it uses all the same Docker image. The image that we're going to use is coming from Google. There's a Google example that includes Cassandra. We're going to use version 13. These are the ports that are defined. So there are intra-node ports, JMX for statistics, and CQL for the client. I'm going to give them limits, so we need 1 GB of memory free to be able to run this pod on the node. So we need 3 GB in total to run this. That's why I added another node. It's 4 T2 small nodes, not T2 micro, so that I have a total of 2 GB per node that I can schedule on. Secure context, we add the capability IPC lock. So we're just going to give a little bit more privileges so that Cassandra can use IPC lock. If we're going to stop the pod, the Cassandra, then it will use the command node tool drain to make sure that the data from that node goes first to the other 2 nodes. Then we have the environment, and this is just what Cassandra needs. It needs, for instance, the heap size. It's going to use half a gigabyte of memory. And then this is the most important, the Cassandra seeds. So where does every node needs to go to for its seed? Because they need to connect. We can have 10 nodes, we can have 100 nodes, but all those nodes need to contact one node that will be called the seed node, and that seed node knows about the whole network. In this case, we're going to use Cassandra 0, which is the first deployment, is the first pod of our Cassandra cluster. And this we can do because we are using static host names. So we can use this static host name Cassandra-0.cassandra, which is a service name, .default svc cluster local. And this host name will always stay like this. So when we use this host name, we'll always reach the first node in our cluster. And that is what the difference makes between a stateful set and a deployment. We give it a name, a data center rack, and then we also pass the pod IP address so that the image knows about the IP address that it's using. There's a readiness probe to see when the Cassandra node is ready. This script is provided with the image. There is an initial delay of 15 seconds and a timeout of 5 seconds. I'm going to mount the volume. So this is Cassandra data. Mount path is /Cassandra data, so that's where we're going to find the data. Then we have the volume claim template. We call it Cassandra data. Read write once, and the storage class is standard. And this is then the storage class that we're going to provide. So it's GP2 in EU West 1A. 8 GB of storage per node. And then we create a service. So this will be the Cassandra service. Name is Cassandra. It doesn't have cluster IP. It will have a port 9042, and the selector is app Cassandra. So this will be the port that we are going to use to connect to our Cassandra cluster to use CQL. Let's kubectl create this Cassandra, and then we can immediately check our pods. So we start with Cassandra 0. So this one is pending. Then we also see the volume. So we have now one volume here, Cassandra data, Cassandra 0. We also have a claim. So if you do watch kubectl get pod, then we can keep an eye on the launching of the pod. So first we'll have the first node Cassandra 0, this is the host name that we're going to use in the config. Then we will have Cassandra 1, that Cassandra 1 will contact Cassandra 0 to tell this Cassandra 0 that it is alive, it is there, and then it will start creating a cluster. Now our first Cassandra node is running. It's not ready yet, but it's initializing. First one is ready, so now the second one is creating, and the second one will contact the first one. And now the third one is creating. So we have 2 ones ready, and now the third one is creating. So let's check again. Now all our pods are running for a couple of minutes now. And we should be able to do kubectl exec of Cassandra 0. And we should be able to execute no tool status, which will give us a status. Don't worry about this error, it's just a temporary DNS error because my cluster is only just a couple of minutes old. So the DNS is not yet propagated to all name servers yet. No tool status gives us UN, status up, state normal of our 3 nodes. So those are the 3 pods, and they are all working. They all have a part of the data in Cassandra. So you have the data and then it's replicated. They communicate with each other and they are all working. Let me just show you how this now works with the DNS lookup. So if you do bash, then we are now logged into Cassandra 0. And if you use ping Cassandra 0.Cassandra, we can ping the first one, the second one, and this is the third one. And in our 3-node cluster, these are static DNS names, so we'll always be able to reach these nodes. Let's try to kill a pod. kubectl delete pod Cassandra 2. Cassandra 2 deleted, and this one will spin up a new pod. It will actually spin up the same pod, the same Cassandra 2 will be spun up. kubectl get pods. So you see there's already a new one spinning up right now. kubectl get pv, and you see no new storage has been created. It's still the same storage that it uses. So it's still the same storage that was spun up earlier. And now it is running again with the same data. So if you do node tool, we have again our 3 nodes in the cluster and they're all healthy. So it can recover, it can contact the nodes again. They have static host names. So you can use a stateful set if you have a distributed database like Cassandra, like Elasticsearch, that you need to run on Kubernetes that needs static host names and static volumes.